Hi everyone, this is Kelvin, the statistician and analyst. I'm back again with another video. This video is Project 5B and it's all about hyperparameter tuning, the logistic regression model. In the previous video, I take you through the logistic regression with the stat models package, but in this one, we're gonna use the powerful scikit-learn package for machine learning. In this project video, we are using the biological data called framing. We are actually interested in classification prediction, whereby we want to predict whether the person will be classified with heart failure or not. This dataset has 16 columns. In the 16 columns, 15 columns are predictor variables, while the last one, which is called 10-year CHD, is a target variable. There is a link to a dataset and a Python file questions attached below in this link. If you are comfortable enough, you can start working ahead of me. And if you are not, don't worry, we'll go through it together. Remember to like, share, subscribe, and comment. Let's get started now. So here, this is called Project 5B, and it's machine learning, hyperparameter tuning, logistic regression, penalties. We're gonna look only at logistic regression model for classification purposes. We're gonna import pandas SPD. We're gonna import also numpy s and p. Start models dot api s sm s here down sm, then seaborn as cns, then matplotlib.pyplot as plt, then sklearn.model under selection. Now we want this for train to partition dataset, train underscore test underscore split. Now we have filled every gaps. Now if I hit shift enter, then we can wait. So now here we can import the dataset, and it's already here. It's a complete. Now if I hit shift enter, now we have our dataset. I said we have 16 columns, and out of these 16 columns, the last one, which is this 10-year CHD, this is our target variable, while the first 15 are the predictor variables or independent variables. Female, this is categorical, and this one age is numerical. Now in machine learning, we don't use the categorical variables, so we have to convert all of these categorical variables such as male, non-current into numerical values. Now here this code is for identifying the data types which are categorical. Now if in Python we call these types of data which are categorical as object data type. Now if I write here and I hit shift enter, we can see that we have sex, current smoker, PMD, prevalent stroke, prevalent HP, diabetes. These are the columns which are categorical. Now we need to convert it into numerical. How will we do this? Now here we will use a powerful function called map. If I put here map function, not here, outside these brackets, dot map, then If it will be male, then it will replace with 1. Female, 0. Yes, 1. No, 0. Current 1 and current 0. Now if I hit shift enter, then we can see there is a difference between the data which we had here and this one. It's already been encoded. Now we want to deal with the next problem, which is checking the null values, whether our data set is tidy or untidy. Now I want to know the number of null values in each and every columns. Now I will use the function is now dot sum, and if I hit shift enter, now we can see that education column has 105 and values. The column with the highest number of null values is glucose, that's 388 null values. Now we need to think how we will correct this problem, which it is incorrect input for any machine learning model, such as this one which we are using, which is logistic regression. Now I want to check the data types. Now before that, I need to check the data types, and then I will use the function called dtypes. And if I hit shift enter, you can see that all of them are numericals. There is integer, float, and this is actually correct because our model does not need any categorical or object data type. Now we are ready to go on. We are in a safe hands, but remember, we still have null values here, which is a problem which we need to solve it. Now I've decided we will impute these null values. Impute means replacing null values with another value. These control structures for loop will do this. Now I'll find mean of each and every column, then I can see which main values will replace each and every column. And if I hit shift enter, I can see education column will be replaced with a mean value of 1.97. Then glucose, which has high number of null values, will be replaced with 81.9. This actually 82, almost 82 values. Now this one will, so these are the values which will replace each and every column. Next, now it's time now to replace these null values with the mean values which we have seen here above. Now how will I replace it? I will use the function called replace. As this one, then I write replace, and if I hit shift enter, we can see that all the values, this line of code replace all the null values with the mean of their respective columns, and then I ask this line, the same line of code, to print whether there is null values in each and every columns, and we can see here our data has no null values anymore. Now we have cleaned our data set. We can still go on to the next step. The next step that we need to do is to select the target variable and independent variable. Target variable and dependent variable, sorry. Okay, here now it's already been coded correctly, and if I hit shift enter, now can go to the next step. Then here I want to know the proportion of those with heart failures and those without heart failures in the target variable. Now let's go count. I'm sorry for that. And if I hit dot count and if I hit shift enter, you can see we have 84% of our data set without of those people without a heart failure, and the remaining 15% are those with heart failures. This is one of the problem in machine learning. Since we trained our model with this data set, we will probably have a problem of imbalance. To correct this problem, we're gonna use a powerful machine learning technique called synthetic minority oversampling technique. There are other methods of solving this problem, such as bugging, random oversampler, underseen, upscaling, and downscaling. But in this case, I have decided to use synthetic minority oversampling technique, which is short, it's called SMOSE. Now, here, first but we partition our data set so that we can have 30% to be test set and the remaining 70% to be train set. So I will use a function train underscore test underscore splits. It's correct. And if I hit shift enter, now we already partition our data set. Now here we want to import some powerful packages which will help us to create our logistic regression model. So first of all, we're gonna import from liblinear underscore model import logistic regression. That's correct. The next one, scalar.import import standard scalar. This for scaling our data sets. These ones, and this from scalar.metrics. This for evaluating our model with some difference metrics method. Implant this for balancing minority groups. Imbalance dot over underscore sampling. Then if I hit, then I think it's correct, and if I hit shift enter, now the coder has not any error. Now here, then let's start now to fine-tuning our model. Now in fine-tuning our model, we will store all our models in a pipeline. Pipeline is a powerful machine learning technique which wrap all of the machine learning models together. It's like a bag which takes in all machine learning models. Now we want to put all logistic regression models with different penalties together. In this case here, we're gonna rename this one with this dictionary data structure, and the key will be L1. This for the first model. The second one will be L2, and the third one we'll call it NET. This is elastic net regression. Then we can check. So the first process will be scaled, then it will be imputed, though we have already imputed our values. it will be inputted with median value, and then our model is this one, logistic regression with penalty elastic net. But there is a problem, because here it should be L1 because penalty, here it should be L2 because penalty is L2, here it should be L1 because it's L1, here it should be called NH, elastic net regression, because penalty that we are using here it's elastic net. Now if I hit shift enter, then we have successfully pipelined our models together. Next, now we want to create the hyperparameters for the models that we have pipelined, we have put together, or we have pipelined. So the first one will be for elastic net regression, which is the keys will be logistic regression. Then here we'll put double underscore underscore underscore. Then what will follow is hyperparameter name here also, and we'll continue. We'll create three separate hyperparameters for according to the number of models that we have. We have three models here. We have three models that we have put in pipeline. We will do the same for hyperparameters. We'll also have three separate hyperparameters. These are hyperparameters for these models. This one is for an elastic net regression. This one will be for L1 penalty, and the second one will be for L2 penalty. Now, after successfully creating separate hyperparameters for the models, next we need to link or to connect the models with their respective hyperparameters. That's why here I will use the name of the models that we created. The first one will be NX. Second one, we use the name L1, and the third one we use L2. And if I hit shift enter, there is a problem. It seems that we didn't run this code above. We need to run first this one so that the next one can work well. Now if I hit shift enter, now we have already linked our models with their respective parameters. Next, what we need now, we need to link the parameters. Now we need to perform, sorry, this should not be this way. We need to optimization. We need to do optimization using grid search CV. You can correct yours if we are moving together. Grid search CV, yeah, that's okay. Now we need to optimize our models. We will, in this case here, we will use another powerful technique called grid search CV. There are some other methods such as using randomized search CV and Bayesian search CV, but in this case I'm using grid search CV. This is because I don't have lots of data sets, so I need to perform every possible combinations of the models. Now if I hit shift enter, now you can see our model, our code is running successfully. There is no error drawn out in. Now let's fit our model. we're gonna fit all of these model once. We have three models: logistic regression with penalty elastic net regression, logistic regression with penalty L1, and the third one, logistic regression with L2 penalty. The advantage with this hyperparameter tuning, this is where the scikit-learn, the power of scikit-learn comes in. Now, scikit-learn plus other Python techniques such as using for loops and dictionary data structure, this will be very powerful. Now, let's run this one. Now, models dot here we are using the fits. We want to fit these model ones, and if I hit shift enter now, we just wait. It will take some time. Yeah, the first is model is train, second one is train, and the third one is train. Now here, now we need now to select the best model with the best parameter tuning. So here what we'll do, we'll use a command. There's a special command which is called models.best underscore params. Here I'll use models dot best underscore params underscore. This will give us the best parameters for each and every model. And if I hit shift enter, we can see elastic net regression has a solver called saga, then L1 ratio is 0.5 and C is 1. Then L1 model logistic regression also find saga as the best model. Okay, next we want to evaluate our model now. Now we'll evaluate this using confusion matrix. We'll not run confusion matrix separately for three different models, just like the way we have trained all these model once. We're gonna also create confusion matrix for the three models at once. Now here we need to use a powerful function called confusion matrix display dot from underscore estimator. Now if I hit shift enter, graphics for confusion matrix graphics will be shown. This one is true, 715, 359, 83, and 159, 615. Let's see another one. The second one is the same, and the third one is somehow different, though has a small difference. Now we can see our model for three different type of logistic regression don't vary a lot. They are almost the same. Now we can do further evaluation. We're gonna evaluate using some other methods such as accuracy underscore, classification and report, and also the confusion matrix. But since we have realized that the three models are doing almost the same, and this might be because the features that we are having in our data set may not matter a lot in predicting the target variable. Therefore, we need to find a way of selecting the best features for predicting the target variable, or we may also need to collect another variable which matter a lot in predicting the target variable. Now let's continue with this evaluation. Now here, predicting the target variable for the new training dataset called x_test. Then afterward, we will evaluate accuracy underscore classification and report and confusion and matrix at once. So if I hit shift enter, wow, a lot of information is about it. Now let's compare whether they are the same. Here accuracy score 0.65, here 0.65, they are the same, and also this one is 0.650. This one, the last one, is little bit lower. And here we can see they are almost the same. So this model is doing the same. The three models are doing the same. So we need to do something about our data sets. Now let's perform another special type of graphical evaluation called ROC curve. This ROC curve will show whether this model has a predictive power. So how will we do this? We'll put the name of our model here. The first one was called nnet. The second one, was called L2, L1, and the last one, that and last one was L2. And now if I hit shift enter, there is a label name here. Should like this one was elastic net logistic regression, and the second one was called L1 logistic regression, and the last one is called L2 logistic regression. These are the labels. So now if I hit shift enter, there is a problem. Don't know where the problem is. The first one was nnet. Oh, this one should not be, this L should be in a lowercase. No. It's a label. This, oh yeah, sure. Forget L here. Now if I hit shift enter, we can now see that we are having our models. Let's see. So we can see the blue line here, but this color, this another blue color is invisible. This is because our model is doing the same. The ROC score, this now is a ROC curve, but ROC score is the same. Now this means that our model has not any difference. Now let's compute. We can compute the ROC score at the same time showing the graphics. How will we do this? We're gonna use a powerful function called plot underscore curve. So here I will use plot underscore rock underscore curve. Now if I hit shift enter, we can see the three separate graphs for the three models and their ROC score. Now here we can see the first one, this net or an elastic net regression that has a area AUC score of 0.68. The next one is L1 regression has 0.68 also, and the last one is also having the same AUC. This means that our model is performing the same. Now let's move this. This was the first method of hyperparameter tuning. We can also do another different way, but in this case we'll not be using a lot of dictionary data structures and for loops, and we're gonna use the pipeline. But in the previous video, but not in the previous video, in this, if we scroll above, we use make and underscore pipeline. There are two different types of pipeline and make underscore pipeline. Now we used make and pipeline, but now we want to use the pipeline. So here we will use a pipeline, but this second method is not effective as the one we have used. This is because this one has some limits and it can be so challenging. So, but anyway, its result to the same answer. Now let's continue. Now here we're gonna pull the pre-processing steps, and the first one is standard scalar initialization. The second one is simple imputer for imputing, simple imputer, and the last one is classifier. Classifier now is our model. Now here we're gonna use logistic regression. Logistic regression. Logistic regression. We are initializing it, or we are instantiating it. Now if I hit shift enter, now we have created our pipeline together with some pre-processing steps and our model. Now here now we need to define or state the hyperparameters for our model. First of all, we start with our classifier. In the top here, we pull the classifier. Our classifier was logistic regression only. We can put as many classifiers such as random forest, decision tree here, but since here in this video or this project we are dealing only with logistic regression, that's why here I've just put the penalty option. But if you have another models, you can try by adding here. For example, the first one is logistic regression, the second one you can put random forest, the third one you can put decision tree. But in my case here in this project, I'm restricted in logistic regression. That's why here I provided only options for penalty. So here first penalty will be elastic net. The second one will be L1 penalty. The third one will be L2. Now if I hit shift enter, now we have successfully created our three models hyperparameters. Now it's time now to here now we want to optimize our parameters using such optimizing parameters models parameters with grid search CV. That's okay. Now here our model this pipe has our models, then param underscore grid is our parameters, and I'm gonna use scoring options of accuracy and verbose equals to -1. Now if I hit shift enter, now we have already optimized our model. Now next we want to fit our models. Now we use a powerful function called fit. Now if I hit shift enter, but I can see there is a problem. Don't know where the problem is. Can't see where the problem is. I can scroll up. Missing get underscore params. Grid underscore search dot fit x train underscore s y train underscore s. There is a missing argument. There's something I didn't run. Now I want to see where the problem is. Now here I forget to put a parameters to close the brackets. No. Oh, here. Now I forgot to open the brackets. Now if I hit shift enter, then I continue. Now it's so continue here. Now our model is being fitted. Let's wait, see whether there is an error again. Let's wait for a bit. This might be a complex formula. Yeah, now it's already complete. Now I want to identify the best model and the best model parameters. So I will use some special command from Python called params, best underscore params. Now here my model is called grid search, grid underscore search, grid underscore search, the best underscore estimate underscore. That's for the best grids here should be grid. Then I'll print the best model, and here I want to get the best parameters. So I'll use grid underscore search, grid underscore search dot best underscore params underscore. Now if I hit shift enter, now you can see our best model is which classifier? Best model is logistic regression with L1 penalty. This is our best model, and it has the parameters of 100, L1. No, that's it. Now we want to predict the target variable with our best model from the new test set dataset called x underscore test. Now if I hit shift enter, now we have already made predictions. Now I want to evaluate the accuracy of a model. Now here I will use the name of the model, which is called best underscore model dot named underscore steps. Best underscore model dot named underscore steps. And if I hit shift enter, now we have accuracy of 0.65. We have used 3 different methods, and we are getting the same accuracy score. From the first method, we got the score of 0.65. Let's confirm. This was our first method. We got accuracy of 0.65. This one also 0.65. The last one, this one is also 0.65. And this last method also we have got accuracy score of 0.05. So this is all about model tuning with logistic regression. Now we have come to an end of this video. Accuracy or predictive power, we need to employ the use of other machine learning models such as decision tree, random forest, XGBoost, and support vector machines, and also k-nearest neighbor. So this we have exclusively exploit the logistic regression, and it's clear that it can't do very good beyond this point, because we have even balanced the different outputs for target variable by including the synthetic minority oversampling technique called smoother. So, but if you exclude the smoother technique, the accuracy will go high, but we have the problem